Hello everyone, welcome to Programming Knowledge. So I again welcome to you all to yet another tutorial at Programming Knowledge. So in today's tutorial, with the continuation of competitive coding with Python. So guys, you can move to this GitHub link and you will get all the codes implemented in Python prior to this tutorial. So today we are going to get started with dynamic programming. The word dynamic programming tells us that we do some computations which are dynamic in nature. Those computations are we calculate something, compute something which are dynamic in nature, and a dynamic programming basically depends on this structure of the problem, that is overlapping sub problems. And we are going to solve today Fibonacci using dynamic programming. But first, we need to think that dynamic programming works on first principle of dynamic programming is that dynamic programming works on many few factors. One is overlapping sub problem. So I would also explain this what is overlapping sub problem. And next thing, dynamic programming depends on memoization. So that is we do memoization. And and third thing is tabulation. So tabulation, memoization. So basically this is 1D, one dimension on array, and this is 2D on matrix. So you can say memoization is on 1D array and tabulation is on 2D array, and the nature of the problem should be overlapping subproblem. So what is overlapping subproblem? I'll tell you, and you can move to this GitHub link and you will get all the codes. And let's start with today's tutorial. So today's tutorial, first we are going to implement in the naive code of Fibonacci series, that is define Fibonacci n if n equal to 0 or n equal to 1, then we return n, because this is the base case. The zeroth Fibonacci number is 0, the first Fibonacci is 1, and then we continue the series. Else we compute this, return Fibo of n minus 1 plus Fibonacci of n minus 2. So I'll define few test cases. T is equal to int input, and for I in range t, n is equal to int input, we take a integer n as an input, and then print Fibonacci of n. Now we'll take some sample test cases. Okay, I'm sorry for the structure of the code. Uh, so I'll take Fibonacci test cases. Yeah, so this is perfect. So I'll also explain how you go. See, this is the number of test cases. 6 is the number of test cases, and I have 6 inputs: 9, 23, 35, 22, 99, 140. So here you can see the ninth Fibonacci number is 34. I'll zoom this. Sorry. So here you can see the ninth Fibonacci number is 34. This is the Fibonacci series, that is 0, 1, second Fibonacci number, third Fibonacci number, fourth, fifth number, sixth number, seventh number, eighth number, and ninth number is ninth Fibonacci number is 34. Okay, so I'll tell you a difference, but before that I'll compute this. I'll copy this test cases, and now what I'll do, I'll run this. So here you can see that I have computed the first two, but I'm waiting for other results. So it is taking me a lot of time to compute Fibonacci numbers of such a long range. So here you can see that the output of the first four test cases had two test cases had come very early, but then just a matter of seconds, then the third and fourth had come, and the fifth and sixth test case, the output of fifth and sixth test cases hasn't been arrived yet, and it is still pending. So what I wanted to tell you that this is not the right approach to solve, because I'll tell you first. I'll discuss the time complexity. See, this is a recurrence relation of t n. For n, I'll compute t of n minus 1 plus t of n minus 2. So this is the reconciliation, because see, for n, for n, depend the value of n minus 1, and the value depends on n minus 2 as well. So reconciliation becomes this, and when I solve this reconciliation, so I'll get the time complexity of this code as 2 to the power n. Okay, so I'll take a difference. Let us consider, let us take a value of n, let n be equal to 10. Okay, with recursion, the time complexity with recursion, I'll say with recursion, time complexity is 2 to the power n, 2 to the power n, and I'll substitute the value 2 to the power 10 is, so we all know 2 to the power, so I'll break this program. So here you can see, so I'll show you the 2 to the power 10 is 1024, so it will make 1024 calculations. So this what cal means, 1024 calculations. And with dynamic programming, DP, time complexity would be, time complexity would be n, I mean big O of n, and this is big O of 2 to the power n also. So, and the calculation would be only 10. So, and plus I'll depend on memoization as well. I'll explain this, what is memoization. Memoization plus memoization in DP. So, so what I'll do, memoization. So, what you can do. So, I'll uh, uh, with memoization, what you can do, depending if you have already calculated the previous value, then there is no need to calculate it again. So, I'll give you a very good example. See, if I have calculated the ninth Fibonacci number, that is 34, so I'll store all these value in an array. I'll store them, because if someone asks me the 8th Fibonacci number in the next test case, so I can already give that answer from the pre-computed value. I repeat, the pre-computed value is very important must here. If, like suppose, if I've calculated all the Fibonacci numbers till here, see the highlighted ones. If I've calculated all the Fibonacci, the blue symbol shows that I have already calculated all the Fibonacci numbers here. So the highlighted with the blue color. Now, if I want to tell this Fibonacci number, I'll tell, because I've already computed till here. For example, if let's take a sample test case here. If I've computed the ninth Fibonacci number to be 34, then I can already tell the 8th one, the 7th one, the 6th one, then the 5th one, then the 4th one, then the 3rd one, the 2nd one, and the 1st one, and the 0th one, because I have already calculated till the ninth Fibonacci number. So I'll show you how we use dynamic programming with a dynamic array in the 1D Fibonacci series. Let's do this using the dynamic programming. Okay, so I'll comment this code just for the I'll comment out this code. Yeah, now what you can do, what you can do, we'll define a Fibonacci dynamic global Fibonacci dynamic list, which is already having a value of 0 or 1, and I'll define a function. So the scope of this list is global list for all test cases. Okay, global list for all test cases. Let's define Fibonacci of n if n less than len of global fib dynamic, then I can return, I can simply return global fib dynamic of n, because I have already computed it. This means have I have already computed for previous test cases. Previous test case. So this means that I have already computed for previous test case, and now we are using that value, and now only returning the value since pre-computed already and no need to compute again. Hence we memorize the solution. Okay, so else if not computed, then compute the value. If not computed, then we compute the value. But I'll show you how we compute this. Else for I in range, I'll tell length, and I'll take the length of this array, comma n plus 1. So I'll make a big screen here. See, and now last is equal to, you can see the negative index. This will return me the last value. The second last value would be -2. Then what I'm going to do, global fib dynamic dot append, I'll do last plus second last, and now what I'm going to do, then return global fib dynamic of n. So here you can see. So then now if I've already computed, then I'll compute from that length of the array, because what's already computed, I'll use the result here. So let me just check the program. If n less than global fib dynamic, okay, perfectly fine. So then return global fib of dynamic of n. Else if not computed, then compute the value using memoization. Perfect. Now how do I compute? For I in range len global fib dynamic n plus 1. So I'll go till n values, and last one would be this, second last one with this. Then I would append the value, and this one return the global fib dynamic. What I can also do, global fib of dynamic of n. Perfectly fine. So let me show you some test cases. So I'll take some test cases, 5 test cases. So I'll zoom the screen. Now if I get to find this, let me show you. This is the first Fibonacci number. So yeah, I have already the first Fibonacci number 0, 1, simply because I have it. Let me calculate the second Fibonacci number. Yes, here you can see how this global array is dynamically updated. Now let me do the ninth one. Simply say, yeah, and these pre-computed value will be used for the next test cases. Please emphasize on this fact that these pre-computed values will be used in the next test cases. So I won't compute them again. These are computed and stored in a global array, and this global array will help me that the next value will be only calculated using the previous one. So let me type another big value. Let me type 50. So here you can see how fast it is, and I get all the Fibonacci numbers. So the last value was this, and let me type another big test cases 140. So such a big test cases, and this is the I guess I had the test case at 140, which was giving me a TLE on that recursion, but such a quick using dynamic programming. So thank you guys, thank you for catching me in this tutorial. I'll catch you up in the next tutorial. Thank you so much.